Do 3 problems from last week's math workshop, so we're going to finish those. We'll just be a little off on math workshop, and that's fine. So just go with what's on the screen, not what's on the board, because the board is for people who are not behind. But don't worry, you won't be behind for much longer. You're very smart. We'll catch up. Okay, number 11. What can we do? Okay. And if I divide by 5, I get A equals. Okay, and someone in first period suggested doing this. But regardless of how you solve that problem, you still get A equals 2. Okay, let's go over number 12. There are 1, 2, 3, 4 terms, so what am I supposed to do? Grouping. Okay, I heard it from 2 and 4. You can have a point. I have 2 groups in here that I've got to work on their points, people. You're killing your grade. The other groups are stealing all the points from you. Okay, on number 12, what should I pull out of that first group? Thank you, Jax. You can have your point. And on the second one, I should pull out A. Okay, and you can have your point, Nick. So I'm left with an x plus 5, and I'm happy because those 2 parentheses match. So my final answer is 4x minus 3y, x plus 5. Okay, on number 13, it's actually the easiest one of the day, even though it's got a couple parts. We want to factor this completely. So how can we factor this? Thank you, Gilberto. 7 plus 3 is 10. 7 times 3 is 21. Perfect. So we've done part A. We have factored completely. We're done. What do the answers represent when you factor the polynomial completely? Justify your answer. Say it again. Yes, dear. That's exactly what I'm going to write. So we have zeros right now, and you can have a point for that. Where and where? Are there any questions about why the zeros are the opposite sides? There were some in first period. They're still frustrated with that. Okay, so what do the answers represent? The answers give us the zeros. Of the graph, which is where the graph. What are zeros?
Where the graphs touch the x-axis.
Crosses. Thank you. I heard it from Angel, so we'll give it to her. The x-axis. Okay, I am smarter than this. Woo. The answers give us the zeros of the graph, which is where the graph crosses the x-axis. I'm smarter than this. Graph sounds a little too generic. What if I want it and I don't want to use it twice? I've got vocab. I can change that. What do I want to change that second graph to a more mathy word? Which is where the coordinate plane crosses the x-axis? Okay, so the more general answer is kind of duh. It's straight in front of us. Polynomial. We could put polynomial. Our graph where the polynomial crosses the x-axis. However, more specifically looking at our problem, our polynomial is a specific kind of polynomial. We have a name for it and everything for its graph. So look at the equation. What do we call that graph? Look at the equation. What do we call that graph? The graph of that is called a blah. Here's a word for it. If we weren't in a hurry, I'd sit all day on this one. That makes me sad. It was a squared one, so we knew it was either a U or an N, so it was either a happy face or a sad face, yes, but we call that graph a parabola. Come on. You got this. Okay, so we're taking a test on Thursday. There are 2 topics on the test on Thursday. One of the 2 topics involves graphing, which is what your checkpoint's on. Can you find the zeros? Do you know about the end behavior from looking at the leading coefficient? So for instance, on our problems today, our zeros are at -7 and -3. So if we were to graph it, -7, -3, that's where we put the zeros. We know since it's a positive 1 for our leading coefficient, since our degree is 2, what do we know about the end behavior? Yes, so since degree is 2 and it's even, they were either going to be both up or both down, because even degrees have the same end behavior. But since it's a positive leading coefficient, we're going with both up. So I know my graph is going to look like this. We discussed the basic graphs of a 2, 3, and 4. For the love, if someone tells me a 2 is a W, I'm going to graph. 4 was the W and M. 2 is either the happy face, the sad face, which could be a U or an N. And then the 3 is the snakes, and we talked about if they were climbing up the wall or down the wall. I'm praying you got all that down. I'm going to find out via the checkpoint very, very shortly anyway. So half of our test is on dealing with this. Now, while you might have a problem asking about the degree, leading coefficient, the number of terms, the zeros, yeah, I could ask number of terms, you will not have a graphing problem that's degree 1 or higher. 2 points. Yes, and you said it first. Degree 5 or higher. Katie's group is 2 points. No degree 5s or higher. Okay, so we still need to do all the graphing things. We still have our maze, our homework from our notes, but most importantly, our checkpoint. In addition to the graphing thing, though, we've got to talk about more factoring, because again, factoring gives us zeros, which helps us graph. So I had someone from your group come get this new packet. We're literally only doing the front page of the new packet. The rest of the packet's for after the test on Thursday. We literally just want to cover the new page of this packet. The front page. That's it. Front page, and we're done. You can confirm that. Yeah, front page, and I'm happy for now. I'm not saying we won't do the homework problems on the back, but front page, and I'm happy. Okay, we're going to try to do the top 4, and then I know you're smart, and we can get through the bottom half tomorrow. So we're just going to try to get through the top 4, and then tomorrow we can deal with the bottom half. That way you have plenty of time to work on your graphing homework and graphing checkpoint. Okay, I want to start with number 1. It's kind of cut off. It's supposed to be x squared minus 9. Can you... Ooh, I almost forgot my name. Woo, words. There's a really capitalized sentence at the top. Can you help me fill in the blank? Very top sentence. Page gets the point. So which problems on this page are going to be an issue for us? Okay, let's look. 5, 8, and what's the third one? And you can have a point, Nick. I'm going to give it to 2 and 4. 5, 8, and 11, because they're not set equal to 0. We're going to have to rearrange those and set them equal to 0. So, for instance, on number 8, I already know I need to subtract 27 because I need it equal to 0 first. But we're not doing that one today. We could, but we're not going to. Instead, we're going back to number 1. I love number 1. It's an easy factor. What is the answer on number 1?
X plus 3.
I know I heard it from 2 and 4. Did 5 say it as well? Did 1 say it and I missed it? Okay. There's no point in factoring unless we're going to talk about the zeros. The whole point of factoring is to help us get to the zeros. So where are the two zeros for this polynomial? Okay. Now that one was pretty easy. I'm going to skip number 2 for now. Why is number 2 harder? Yes, literally because of that sign change. You have to point to that. Because of that sign change, it's going to be a hard one. Let's go to number 3. Number 3 should be fun. What can I do on number 3? Okay, and you can have the point now. And then what happens? Where are my zeros?
-1 and positive.
No, she's out.
-1 and positive 3.
No. Thank you. Again, for the zeros, if you're having trouble with that, all I'm doing is setting each of the terms equal to 0. So if I set 3x equal to 0, I get x equals 0. If I set x minus 3 equal to 0, I get x equals 3. I just tend to do that in my head, so I go ahead and list them. Number 4 is another lovely one, or so it seems. It looks like the difference of perfect squares. So we're going to treat it like it is. You can still handle it even though it's a 4 exponent. You've still got this. You know all your perfect squares. Just still know the answer to 4. He's so close. Yes. 2 and 4 is a point. Yes, the square root of 4 is 2. We need those twice. We need it in front of the x, and we need it with the exponent with the x. And then, of course, square root of 25 is 5. So that's perfect. However, we're not done because we still need our zeros. So I'm going to have to set each of these equal to 0. So if I set 2x squared plus 5 equal to 0, and I set 2x squared minus 5 equal to 0, now I would have kept factoring, but I didn't know how to factor that. So this is my next option. I'm just going to have to solve. Okay, so on the right one, I get 2x squared equals 5, x squared equals 5 over 2, and then what do I do? Say it. Yes, and you can have a point. We got to take the square root of both sides because we want to get rid of that x squared. So it's going to be x equals plus or minus the square root of 5 over 2. Great. So we had something to the 4th power, which meant we were going to have up to 4 zeros. So if we were making a list of our zeros, we've already got 2 of them, positive square root of 5 over 2. And negative square root of 5 over 2. We just need to figure out the other 2 zeros. Okay, so on the other one, I subtract 5, so I have 2x squared equals negative 5. X squared equals negative 5 over 2. I take the square root of both sides again. I get x equals plus or minus what? Say it again. Yeah, it's still going to have the square root. It's going to be 5 over 2. But go back to realize, hey, I've got that negative under the radical. That's when I need I. So my answers are plus square root of 5 over 2i and minus square root of 5 over 2i. What does the I stand for? Yeah, I was for imaginary. I was for imaginary. Okay, so you and I are graphing. Here's the y-axis. Here's the x-axis. Is the x-axis imaginary? Think about the numbers on it. Does it have any crazy... I mean, it's just numbers, right? So we've actually talked about this before, but you've forgotten. And it's okay. Tell me about these two spots on our graph. Tell me about the two imaginary spots on our graph. Does someone know? And you get 2 points for that. Now, I understand on this next test you don't have your graphing calculator. I'm literally just wanting to prove a point because I'm a math teacher and I just can't let things go. As long as you got your zeros, Lord knows you're fine. I graphed the equation 4x squared minus 25. Notice how it only crossed twice. The two spots it crossed were at this decimal and this decimal. Because this is somewhere between 1 and 2, and this is somewhere between -1 and 2. It doesn't cross here or here. The imaginary numbers are not actually on our x-axis. Okay. We're going to let that one go and go back to number 2. Any thoughts on number 2? Thoughts on number 2? Do you know how to factor that, x squared plus 9? If you did that, where'd the middle go? Where'd the middle go? Where'd that 6x go? I don't know how to factor it. I don't think it's factorable. I don't think we can factor that. I think we can solve for x, but I don't think we can do it with factoring. So...
If we can get negative 9 in our mind, is it because it's...
Because when you actually FOIL this out, because it's a positive 3x and negative 3x, that when you FOIL it, the O and the I, the outer and the inner, end up canceling out. When they're both positive, the outer and the inner do not cancel out. But on this one, if we FOILed it out, it would be x squared plus 3x minus 3x minus 9, and then the outer and inner really would cancel out. Okay, so I'm here. What do I do from here? I need an answer. That's not an answer. We just did one just like this. Number 4 was way harder. Okay, so if we take the square root of both sides, I've got plus or minus the square root of -9. So my final answer is going to be yes, ma'am, and you can have a point for that. So since we got imaginary answers anyway, so our zeros are imaginary zeros. They're not actually going to cross our x-axis. So we have imaginary roots. So positive 3i, negative 3i. We're not actually going to cross there. So we should have known we couldn't factor it to begin with, I guess. That's the moral of that story. Okay. Before I let you go work on your checkpoint and the many things that you've not shown me that you need to show